Hey guys, so we're talking about factors and multiples and also prime and composite. And I've got a very good teacher here next to me who's going to help me out with this so I don't make any mistakes.
Hi.
Wait, who are you?
I'm Mrs. Thomas. I'm their teacher.
Oh, so you're going to help me out here today, right?
Absolutely. I will be here to assist you as you teach the lesson.
As I teach a lesson.
Well, you said you wanted to. You were complaining that I was the only one able to do all this stuff, and
This is true. So you let me speak this time.
I am.
Okay. So, guys, we're talking about factors and multiples first. To be more specific, we're going to start out with factors. Factors are the two numbers that multiply together to make up a number. Take, for instance, we have the number 12. Now, there's a couple different ways you can get to that number. One of them being 1 times 12, 2 times 6, and 3 times 4. Hey, look at all those numbers. They're all individuals, right? They make up the number
Absolutely.
when they're paired with the right order together, right?
Absolutely.
Okay, so if I had to split them out, then I would say that, if I'm factoring out 12, here are my factors. It would be 1, 2, 3, 6, and 12.
Well, here's the problem. You missed one.
I did miss one.
You did.
So that'd be 4.
Absolutely. Don't miss the 4 because the 4 times the 3 is what gets you to 12.
6 and 12.
Absolutely.
Okay. Interesting fact there. Now, another thing with this here, and I believe we call these factor sets, correct?
Close. Factor pairs.
Factor pairs.
Factor pairs. Because
Okay.
it's a pair of numbers. There's 2 of them.
Right, and if you don't have them correct, you're not going to get to that number.
No, you're not.
Like I can take 6 times 4, and that's not 12, that's 24.
Yes. So how many factor pairs do you have?
I have 3 factor pairs, so I can get up to 12.
Yes.
Okay.
And how many factors?
I have 6 factors.
Yes.
Okay. So if I'm also factoring out the number 4, for instance, I would have 1 times 4 and 2 times 2, correct?
Correct.
Okay. And in this case, my factors would be 1, 2, and 4.
Yep.
Okay. Now, wait a minute. The 2's not, there's a second 2 there, but I'm not putting it here.
No, you don't need to because the 2's already there.
Okay, so this is just defining the single numbers that are used to make up the number, right?
Correct.
Okay. And again, that's 2 factor sets and
2 factor pairs.
2 factor pairs, excuse me. 2 factor pairs that make up the number, and that's 1 and 4 and 2 and 2. Again, they have to be in the right order, otherwise you won't get that number. You get some other number.
And how many factors?
There's 3 factors total.
Thank you.
Thank you much. All right. So I think we got factors down for a little bit here. Do we need to do another one? Do you think?
I think we're good with factors as long as you remember that they are factor pairs for the 2 numbers that multiply together to make whatever the number is that you're looking for the factors of. And that each individual number is a factor of 12 or 4 or whatever the number is that you're looking at.
Okay.
So 3 is a factor of 12. 2 is a factor of 12. But 2 and 6 are the factor pairs for 12. That's one of the factor pairs. But things are different if you're talking about arranging things.
That is true. Things are a little bit different when I'm talking about arranging things. Now, we only stopped here at the 3 and 4 and look at number 12. We only stopped at 3 and 4.
Right.
But we didn't continue it down.
No.
So you can also continue it on if you were doing it. So along with 12, let's rewrite the factors again just to make sure we have them down. So you have 1 and 12, 2 and 6, 3 and 4, 4 and 3, 6 and 2, and 12 and 1.
Absolutely. And do you know why we do this when we're talking about arrangements?
Now, we're talking about arrangements here, right? So arranging is, how am I going to, say, arrange my results, or if I'm making a chart or something of that nature?
Well, I think of it more as placing cards on a wall or on shelves on a wall or placing stickers in a book, things like that.
Okay. So basically what you're telling me here, so if I'm reading this right, so if I have stickers in a book, I have 12 stickers that I want to put in a book. I can have them all in one row of 12 stickers,
Yes.
right?
Or on one page.
One page, so one page of 12 stickers. I can take 2 pages and put stickers on each page.
Mm-hmm.
3 pages, put 4 on each page, and so on. So I can put 4 pages with 3 on each page, 6 pages with 2 on each page, or 12 pages with 1 on each page.
Absolutely. So if you have really big stickers, you're not going to want all 12 stickers on one page. You may want one on each of the 12 pages. It just depends upon how you're wanting to arrange everything. It also depends on size, all that.
Interesting.
Yes.
Okay.
So when you're arranging, it's different than just finding factors or factor pairs. Because when you're looking at factor pairs, you don't want to double your factor pairs because you already have it. It doesn't matter if it's 3 or 4 first. But when you're talking about arrangements, it is different because having, let's say we want to put my porcelain dolls on shelves on the wall in, I don't know, the guest bedroom and have all the dolls in there. And if I want to have all the dolls, let's say I have 12. I don't, I have more, but let's say we have 12. And I want to put all of them on a single shelf. That's going to be different going to the store to buy than if I wanted to put each one on its own shelf. So I would need 12 shelves in that case. That's going to be different when I go to the store to buy. So that's why arranging is different than just finding factors or factor pairs.
Okay. So you don't ever want to put more on one location than you have some room for it on. So you want to make sure you arrange stuff properly to get it where you're going.
Correct.
Okay. Interesting. So multiples are, in a sense, skip counting. So what I'm doing, let's say I want to grab multiples of 12. So I can take 12, say, times 1, which is 12. I can do 12 times 2, which is 24. 12 times 3 is 36. 12 times 4, which is 48. 12
And
times
so
on. Yeah, and so on. Now wait a minute. What's the pattern here? I've incremented stuff, looks like by 12, correct?
that is correct.
So I'm not counting by ones or twos. I'm skipping it by 12 every single time.
Absolutely. So what you're looking at is multiplying your number that you're trying to find the multiples of by your counting numbers. So by 1, 2, 3, and here is 4. And you can continue on until you want, but you always want to go maybe 4 or 5 depending upon what they're asking you, and then move on from there as needed. So you don't do 10 of them and then realize you only needed to do 3 multiples.
Oh, okay. That makes a lot of sense there.
There you go.
So if I wanted to continue on with another example, say if I wanted to do multiples of 10, or 4, multiples of 4. So if I'm counting it right, I'm looking at 4, 8, 12, 16, 20, and so on. And it's the same way. I'm counting it up by my counting numbers. I'm going from 1, 2, 3, 4, and 5.
Being multiplied by 4.
Be multiplied by 4. Another pattern that I noticed too is when you're doing multiples, it's also incrementing up by 4 every time.
Yes, you're adding 4 to the number that's before it.
Very cool.
Because with multiplication, all it is multiple addition.
Okay. Alright, so we have a word problem here. Alfred is arranging 40 model cars in rows, and he wants to put the same number of cars in each row. Find all the ways he can arrange the cars. Keywords that I'm going to point out here for you is the word arranging. That means they need to arrange That means you need to find all the ways that you can arrange the cars and put them in each row. In other words, when you make sure that you're doing arranging is the word arranges. That's giving it away too, correct?
Correct.
Okay.
So you have to know how many rows and then how many cars are in each row.
Each row. So we're going to do a T-chart again. And this time we're going to put 40 at the top of the T-chart, correct?
Correct.
Okay. So if I'm going down the line here, I'm going to be doing 1 and 40, 2 and 20, 4 times 5, 4, no,
We're looking at 40.
40. Okay, that's 4 and 10. My apologies.
There you go. Always double check. Make sure that you're right.
Always double check them. 5 and 8. Now, these are my factors, so we're actually going to continue on because we're doing arranging, so we want all the possible numbers. So it's going to then be 8 and 5, 10 and 4, 20 and 2, and then 40 and 1.
Absolutely. Because this would be here, this would be the rows, and this would be in each row.
Okay.
So how many ways can we arrange the cars?
Let's count them together. So it's going to be 1, 2, 3, 4, 5, 6,
Slow down.
7, 8.
There you go.
Interesting. So I can have 8 different ways that I can arrange these cars in the rows.
Absolutely.
Okay.
Very good.
All right. So here's another problem. There are 12 levels in Liang's new game. If you place the same number of levels each day, what are all the possibilities for the number of days you could spend playing the game without repeating a level? So on this question, we're going to do it this way. Hit the pause button and finish and do this question for me. When you're ready, when you finish with the question, come on back. We'll work with it together. And we're back. So we've got 6 different possibilities that we can accomplish this task here. How many days can we spend playing the game without repeating the level? If you look at the T-chart on the right, we have one side labeled days, one side labeled levels. It's very useful to label your sides so that you know what you're talking about there. In this case, and then looking at the way you rearrange them, I can do it either 1 and 12. One day I can play 12 levels. In 2 days I can do 6 levels. In 3 days I can do 4 levels. 4 days I can do 3 levels. 6 days I can do 2 levels, or 12 days I can do 1 level, excuse me. And there's just different ways that we can arrange it. 6 different possibilities that we can accomplish the same task. And now, guys, we're going to go on to my favorite subject, which is prime and composite.
Hey guys, I'm back. So Ian wanted to make sure that this part got taught correctly, so he has given the reins back to me, and I'm just going to quiz him to make sure that he knows what he's doing, because we know last time he didn't know what he was doing, but he doesn't need to know that.
I can hear that.
Oops. So we're going to talk prime and composite. So when you're talking about prime and composite, you're looking at a number. So let's say the number 11. Now, to figure out if a number is prime or composite, you have to know the factors, okay? Which is why we talked about factors first. So with composite numbers, that means that you have more than one factor pair, okay? That means that you would have 2 factor pairs or more. So a prime number is the opposite. It is just that number and 1 as factors, and that's it. So let's look at 11, okay? So if we're looking for factors, that looks like a smiley face. So I'm looking at 11, and I'm looking for all the factors of 11. So I know 1 and 11 are definitely factors. Ian is finding this very amusing. Now, I need to see if 2 would work. 2 would not work because 1, the one that's in the ones place, is an odd number, and 2 only works with even numbers with divisibility and being able to multiply by another number to get another even number. It doesn't work for odd, so 2 doesn't work. 3, I have 3, 6, 9, and 12. It's not 11. 4, I have 4, 8, 12. Again, that doesn't work. 5, I have 5 and 10. So no other number is going to work for the number 11. So 11 is a prime number. Okay? 11 is prime, which means that the only factors are 1 and 11. Okay? So there's only one factor pair, two factors. Okay? So let's take a look at a different number. Okay? Let's say we're going to look at the number 12. Okay? Now, for 12, we know that 1 and 12 work. Okay? And we did this number earlier. So, does 2 work as a factor of 12? So, 2 times something equaling 12. Yes, it does. So, 2 and 6. As soon as you find another factor pair, and you are 100% sure that these two numbers equal this, it is composite. You do not have to continue anymore. This is a composite number because we have at least 2 factor pairs. We have more than 2 factors, more than 1 factor pair. So this is a composite number. Okay? So let's take a look at a different number. And let's look at 38. Okay? Now, the first thing you want to notice is the 8 in the ones place. This is the perfect way to see if this number is prime or composite, because all even numbers, with the exception of 2, are composite numbers because you can always have 2 as a factor. So because this number is an even number, 38 is composite. And you don't have to do anything else. You don't have to make a T-chart or anything. Because this number has an even digit in the ones place, it is automatically composite. All right? So let's take a look at this here. Okay? Janae has 36 pennies. Nate has 23 pennies. Who has a composite number of pennies? So Ian. You hear Ian?
I'm here.
All right, so you paying attention?
Yeah.
Okay, good. So I need to find who has a composite number. So composite, does that mean 1 factor pair or more than 1 factor pair?
More than 1.
Absolutely.
So to get to this answer, I need to then factor out those 2 numbers.
Absolutely.
So if we're gonna do is, I guess, 2 T-charts. One's gonna be 36. The other one's gonna be 23. So if I'm factoring them out, and we'll do the 23 one first, it's going to be 1 and 23. There's nothing else that goes into that number.
Does 2 not work?
2 does not work.
Why?
Because if I'm using my counting numbers and if I remember my multiplication right, the highest that 2 will go is 24, which is 1 off from with as far as I need to go to, it's 1 off from 23, a little more.
Right.
Nothing would equal 23 directly from 2.
No.
36, on the other hand, I have 1 times 36, 3 times 12.
And you can stop right there.
Yeah, there's no more point, because the definition for composite is it's got more than 1 factor pair.
Absolutely. So which one is composite? 36 or 23?
I would say 36 because it matches my definition of more than 1 pair.
Absolutely. I just want to make sure that you knew what you were talking about.
So then that would make then 23 termed as a prime.
Absolutely.
So prime is when there's only 1 factor pair available. Composite when there's more than 1 factor pair available.
Yep.
Okay.
So there you go. So that is how you figure out prime and composite with your word problem. Okay? Now, here's another way that you can look at prime and composite. Okay? So if you were to make models, let's say you wanted to do 36. Okay? So here I have 4 rows, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9 in each row. Okay, now that's not one that we did over here, but it doesn't matter because I remember as soon as you have another factor pair that you know equals 36, you know it's composite. But another way that you can do it is you can make an area model. Okay, so you could have done by 2 and then gone through until you got to 36 to see, okay, does this work? And as long as you can make another model with rows and the same number in each row, you know that this is composite. Okay? You can have 1 row of 36, or you could have 4 rows of 9. There's many different ways to get to 36. But with prime numbers, you can only have one area model where you have 1 row and you have all of those in the 1 row. Okay? So you would have here 1 row of 23. That's how you know that it's prime. You can't do anything else. 2 wouldn't work because you would have an uneven number. So here I have 23, but there's nothing here. So this guy right here is all on his own. That's not good. We can't have him by himself. He has to have a partner. Okay? So if nothing else works, then it just doesn't work. Okay? So it would be prime. Have fun with it. And here is the one that you guys are going to do. And then come back and get the answer. So it says, basketball team scored 37 points in 1 quarter. Is the number 37 prime or composite? So pause the video and then come back when you're done. Alrighty, so here I have 37 factored out. There is no other number that I can do to multiply to get 37 by a whole number. It's just 1 and 37. So since I only have 1 factor pair, is it prime or composite, Ian?
Well, look at the definitions. That's going to be a prime number.
Absolutely. It is going to be prime because there is only 1 factor pair. Now these next 2 you guys are going to do on your own and then bring me in the work. Sorry that the video was a little longer than normal, but Ian had a lot of fun doing the first part of the video, and I hope you guys enjoyed it as well. So here is your first one, okay? So here it says which list shows all the possible numbers. It is one answer. It is not a multiple answer choice here. There is only one option that shows every single option for the cars. So you only pick one of these. Do not pick 2 or 3. It's just 1. Okay, so go ahead and pause and then come back for the last problem. And then this is on prime and composite. So when you're done, go ahead and put your stuff in your notebook, your binder, your folder, somewhere that you will remember to come and bring me tomorrow. Remember, you have to do the work, guys. You can't just watch the videos and expect to do better unless you actually practice. Okay? Watching the videos is good, but do the work as well.
I can highly recommend doing the work because that's how I find remember which ones are which.
There you go.
Failure to do your work means you more than likely will not remember what you're doing. Practice makes perfect, guys. So remember to bring it in and bring your work back to Mrs. Thomas during your next class.
Thank you, Mr. Thomas.
Yes, Mrs. Thomas.
I will see you guys later.
See you.
Bye. Bye.